Yes, go ahead.
Okay. Yeah, it's being recorded now. Okay. Sorry. Okay, let's start. Today we're going to talk about artificial intelligence and machine learning. And the title I baptized this session is Electric Sheep Dreams Are Made of This. I hope that most of you grabbed the references there. There are two references. Basically, we are going to talk about the core for each of artificial intelligence projects. So let's start with that. What's the first thing that pops into your mind when you hear artificial intelligence? Can anyone share his answers? Oh, nobody? Okay.
Simpat bot.
Simpat bot, okay. Any other example? Yeah, don't be shy.
There was one about Google that you can make. It's like a bot. You can start talking with him, but I don't remember their name.
Okay.
It was quite popular a couple of years ago.
World domination.
I remember that. Okay. To be honest, I think that most of us will think on these examples when we hear artificial intelligence. We think on the Lost in Space robot, or R2D2, or even Ultron, or on the cute side, Wall-E. But those are not real life examples. We are not yet on a state where we can have this kind of robot, this kind of intelligence. So in real life examples, we are very good, I think. We have Uber. They use artificial intelligence to estimate the time arrival of their trips, or the price search estimators. Gmail using artificial intelligence for filtering the spam, and they do it very good. 99.99% is filtered on every Gmail inbox, on every Gmail user inbox. Also, another example, it's Amazon with the recommendation system they have. For me, they recommend stuff that I was aware of, and end up buying that and liking that. I have grabbed a couple of books based on this recommendation system, and they have been very, very, very good books and very interesting. So it's like mind reading. You're just browsing for I don't know, for Mother's Day gift, and they recommend you I don't know, a Switch game, and that's very good recommendation based on your state of mind. Also, we have Facebook with the face recognition. When you upload photos, and they start tagging all your friends and even yours. It's very good. And assistants like Siri or Alexa, or even Cortana are actually good examples of artificial intelligence. So we're going to talk about that, artificial intelligence and machine learning. So we can define artificial intelligence like a computer program that does something smart. How we know if it's doing something smart? When we do something smart, we can say we are taking decisions. Decisions are a measurable value. So we can take good decision, bad decisions, smart decisions. And how we end up taking decisions? Well, we first start with our environment, the world that surrounds us. We have our senses. We have our eyes, or nose, or hearing, or touching, and everything. So, for example, if you move to a new city, have a new job, you start taking the quickest route to your work, to your office. And one day it takes one route, route A. Then the next day you try something new, route B, or even route C. And let's say that in a month, you end up having a lot of experience. You know that, for example, route A takes 30 minutes, and it's a constant 30 minutes. But on route B, you end up getting that probably it's fastest, probably 20 minutes, but most of it's random, it's not constant. So it's very risky to go through that route. End up probably in 20 minutes arrive to your work, or probably more, like an hour or something. And at the end, you end up with a mind model, a mental model of all these people from your environment. You will learn from experience, and even we don't need to remember everything that we do. We just train ourselves somehow and end up with a mental model that will, it's our interpretation of how we think that the world is behaving, the behavior of the world. And based on that, we end up taking decisions. We can take smart decisions, or good or bad decisions. So probably if you are going to work and it's raining, you know that you will take more than two hours. Well, in Monterrey, that's the norm. More than 2 hours to arrive to the office when it's a rainy day. So you know that it's better to based on your experience, you take the best decision. So how do we translate this into software? Well, it's the same steps, but we move to data. Our world is our data. We collect data from any source. We can collect data from databases. We can collect data from analytics, for example, from Azure uptimes and everything. We can grab data just doing a query on the database, or if we have IoT devices that are pushing data, also it's a good source. From that data, we analyze that data and learn or create what ends up like a very specific, a very precise mathematical model of how we think that the data is behaving. And with that model, we can take decisions. So all these steps are artificial intelligence. And the other part of this topic is machine learning. So machine learning is just the data collection and defining a precise mathematical model based on how the data behaves. So for today, we are focusing on these first two steps, data and learning from the data. So sorry, we are not going to work on writing the next Skynet. So we can leave that to the evil geniuses here out in the world. Okay, so let's start with what is called exploratory data analysis. This is one of the crucial steps in data analysis process. It's what we are going to do before start modeling or start making models of the data. We need to analyze the data, look for all the context, try to understand the best we can the data we are dealing with, and with that we can create a very good model. the importance of this exploratory data analysis is up to 50% of the time for each of the projects related to artificial intelligence. Most of these projects, up to 50% of the time is spent on grabbing the data, procuring the data, cleaning and exploring the data, and is comprised of analyzing the data set. We have the data set, we know how many browse. A data set, you can look at the data set like an Excel spreadsheet. We have columns and rows. This is the best I can describe you the data set before we take a look into an example. So analyzing the data set, how many rows are there, how many columns, which kind of data is on each of the columns. We have numerical data, date times, for example, or categorical true, false, stuff like that. We make a summary of the main characteristics of the data set. The main characteristics like, for example, the histogram or the mean or standard deviation of each of the values. We also detect anomalies and outliers, the stuff that ends up making or adding noise to our data set. So we can have a very good bell-shaped distribution, but some of the data it's outside of that and probably ends up, sometimes we need to clean those outliers, or we just need to be aware of them. And also includes visualizing patterns or trends. We use plots and graphs to visualize the data. We can check the data by variables. Sorry. So, for example, univariate analysis, we can just plot a single variable or plot a bivariate data. So this is two data like X column and X and Y with different data there. So for example, we can check how time is related to time you study is related to the performance you get on an exam or stuff like that. And a multivariable analysis that is including most of the data and how each of the columns is related to each of other them. Then we have types of variables. There are mainly two types of variables. We have categorical data. Categorical data, it's described in categories like gender or date of the week or even a year. Is a categorical data, is data that is discrete or even a true false. And we have continuous data. Continuous data is something like a salary or temperature. After that, we start with doing descriptive data exploration. That includes a lot of statistics and stuff that we learn it at college, I suppose. You have the measure of central tendencies like the mean, the median, the mode. The mean is like the average of all the data for a specific column. The median is when you order this data from in an ascending or descending, the data that is exactly in the middle, and the mode that is the value that is more frequently that has more frequency on our example or on our data. And then we have measures of dispersion that includes the quartiles, the percentiles, the standard deviation, the variance and the covariance and everything. We can do a quick view on using there is a function on Pandas, one of the libraries that we are going to use on the example that describes all of this. Is called describe, and it shows this we can see that we have on the top, we have the columns, and on the left, each row represents one value, like the count, the number of values there, how many values are unique, what's the most frequent, the top value there. And then we have the mean, the standard deviation, minimum and maximum values, and the percentiles. And we can see here that, for example, the port name is a discrete value. That's the reason why we don't have a valid value for the mean and everything, because it's a discrete value. We have only the unique counts and which one is the top and what's the frequency of that. Or for example, on the value column, we know that it's a numerical value and have a lot of data there. With the standard deviation of 1.5, with a minimum value of 0 and a maximum of 4. Okay, that's a basic exploratory analysis that we do with data. And the tools we use to do that is, or the tools we're going to use that for that. It's the first one, Jupyter Notebooks and Anaconda. Well, Anaconda is like a package that includes a lot of tools, even includes some tools that are specific for the R language. But I think that we as developers will be easiest for us to learn Python. Even Python is very easy to move. If you are well versed on C#, you can move to Python. Just looking at some library references, most of the logic is the same. And that's the main language that we are going to use with Jupyter Notebooks. Jupyter Notebooks is an excellent tool to run or Python code. I'm going to show that later. The next one, well, these are Python packages. The first one is NumPy. It has a lot of, it's a package that has a lot of methods to deal with data on a series, or you can see that like an array or a matrix. You can do stuff like convert values to data, to datetime, or normalize data using some exponential functions. And it's a lot of maths there, and it's very helpful. The other one is Pandas. This is the main that we use to loading data sets and working with data sets. It provides us with tools like join. When, for example, you have two data files and need to join them, you can use join just as the same as we are used to use join with SQL Server. Or this is the library that is used to import these data sets. We can import from the CSV files or Excel files. We can load our data frames from those sources. Also has a group by methods, and it's pretty useful to start with our exploratory data analysis. And next we have Seaborn and Matplotlib. Those are visualization libraries. They have packages to display bar plots, p-chart plots, scatter plots. All kind of visualization are provided by these two libraries. So, okay, let's move to our case study. I found there is some data on the US border crossings. I was planning to analyze data based on coronavirus, but I think that we are very full of that. So this was a better option, just because it has a lot of data, all of the from 96 to February 2020 of this year, all the incoming crossing counts into the US. has 7 columns with specifying the port and the state, on which border it was, in Mexican border or Canadian border, how many people crossed the border, and the date and time and the state and everything. So for that, we are going to use our Jupyter notebook. This is Anaconda. It's running here, and we're going to use this one. I already had it open here. Okay. Okay, have this. So any questions so far? Okay, so the first thing that, yeah?
No, I just said no, sorry.
Okay. So, well, this is our Jupyter notebook. It has, it's works defining cells. Each row is a cell. We can define cells as a markdown cells or a code cells. For the markdown, we can draw, put some text there or images, and just make definitions. And the code can be executed here. We can use this button to run. So I'm going to start importing our main packages that we use. And then we are going to load the data. We can see that we imported now as MP. Pandas is our PD library. So I'm going to use PD, and the method is readCSV. This is the file that I have, that I downloaded. You can see it here. So just let's run this. And we already have the data loaded. How we can be sure of that? We can just use the method have, and it will show us the first 5. This is the default. If we can see, if we can look for more. For example, using a 10, it will show 10. It will show 10 registries. The first 10 registries of our data set. We can see that we have the port name, the state, the port code, which border, and the date. And measure is the type of vehicle. We have personal vehicles and stuff like that. And or the value, how many people entered using that measure on that specific date, on that border, and the state, and the port name. There are some other methods on our using our Pandas data frame. So for example, we can get the information of all the data, and it will display all of the columns, which how many values are non-null. We can see here that there are non-null values, and the data type, for example, all of them are objects or strings. By default, they are treated as strings, and this could be an issue with the date because it's an object. So we will need to deal with that shortly. So yeah, here we convert our data to date time using Pandas. Yep.
Sorry to interrupt. I think you are sharing only the screen on your presentation. If you have a second monitor, probably you are sharing the incorrect one.
Okay, sorry.
Or maybe you have to share your entire desktop.
Okay. Are you seeing the Jupyter notebook now?
Yes.
I see it, yes.
Okay. Thanks for that, Heavy. I wasn't aware. So let's start again. This is a basic our Jupyter notebook running. Okay. So Jupyter notebook works defining cells. Each row it's a cell. Okay. And we can change the cell type from markdown or code. On Markdown, we just define basic Markdown text and execute the cell, and we'll display those our data. And on code, we can write Python code. So for now, I'm gonna first import our data or packages, and then using the Pandas packages, we are gonna read the data. The data set is border crossing entry data.csv. It's a CSV file. And to be sure that we loaded the correct data set, we can use the data head method, and it will display the first 5 by default. We can play with this, and instead of displaying the first 5, we can display the first 10, or even there is another one that displays us the last tail. Sorry, it's tail. The last values. They have actually they are ordered by date. So the last one is the first registered value, and you scan the border. Okay. So there are other methods like the data info. It will display us the information of if on each of the columns we have the port name or state the names of the columns here, the non-null values. So on all of them, we have 355,000 values that are not null, and that's our entire data set. So we don't have any null values, and that's important just to be sure, because if we have null values, we need to deal with them later, like replacing those null with median or mode or with any of those values or the most frequent one. And the next thing we can see is the type, the data type. We can, by default, Pandas will treat the object as a string. And this is an issue on the date, because if we try to search the data filtering by date, working with strings doesn't work. So we need to deal with that using, there is a Pandas method that will convert our data to datetime. So what we are basically doing here is replacing our current values with the same values converted to datetime. And then we can just execute info again, and it will say that our date is now a datetime object. So it's good to continue working on that. And this is another method to verify that there are no null values here. We just filter from our data all values that are null, and then applying a sum method there, and it will display that none of the columns has a null value. All of them are 0, so there are no null values there. The other method that we use to analyzing basic data sets, the data sets, is the data shape, or sorry, the data is for data frame name. The method is the shape method, and it will just tell us the number of rows and the number of columns. And there are some other stuff like we can do with our Pandas library. So here, for example, we can display an histogram on the full data. This will just display us some graphs on the numerical values. So it will only display us the port code and the value graphs for, you can see the port code and the value. The port code is a numeric value, but it's not relevant to any analysis because it's just another representation of the port name column. So we can remove that later. So other stuff that we can do is group, for example, let's say how many how many people cross a specific borders. One of the specific borders we can group by the border, and then on the column value make a count. And then there is a method for plotting that. We just define that our X will be the border or Y value will be the value. And we are displaying a bar plot. And we can see that apparently there are more events on the US and Canada border than in the US-Mexico border, but that's because we are doing a count. A count is just displaying how many rows for that group are. So if we change the count with a sum, we have the total values, and there is a huge difference. There are more people crossing on the Mexico side in all of these years, and accumulate is greater than all the people crossing the US-Canada border. Or change this method for the mean and just have an average, and it's even more on average crossing people crossing the Mexican border. We can look at other columns like the measure. Measure is the type of vehicle that was used. We again group that by the measure and then use a value count. We can use a value mean. This reset index method is just used to move our data to have valid columns for the plot to display. I'm going to show you this after this. So these are our values for the measure. We have that personal vehicle passengers are is the most used mean of entry on the borders. For example, the other thing I was not to show you is the difference between using or not the reset index. Yeah, this just give us a single table, a single data frame, single series data frame. That's the only, that's our measure and the count and the value count. And if we reset the index, sorry, it will give us a data set with 2 columns. So what we are doing is just moving. Originally our measure was the index, so we reset that and added a numerical index, and now we have 2 columns, one for the measure and one for the value, and that's why we can display this bar chart correctly. For example, we can also go to using the data column and look for all of the unique values there. So there are 290 unique date values. But this is there is a lot of data here. So let's focus only on the Texas border side data. So we are creating a new data frame here called data_Texas, and we are filtering from our data that the state equals TX and making a copy of this to avoid references. So if we do any changes on our new data set, using this copy will prevent these changes to be replicated on the source. It's like passing the value by value or by reference on any methods on C#. So we just to be sure to have a clean copy, a new copy of the data, filter it on Texas, and we can compare the shape. We have less values here, almost 10 times less values, only 36,000. And if we describe this, it will show us what we saw on the presentation. We have all of the values. If we remove this, we only have a description of the numerical values. We have the port code and the volume, but let's include all. There are 12 port names, actually. Only one state. The port code it's a numerical value, so there is no unique value there. There is only one border, the US-Mexico border. We have 280 unique dates and 12 different kinds of vehicles used to. And the top one is the pedestrians we can see here. The port with most records is El Paso in Texas, with a frequency of 3,000. And we can have a good insights on our data here. So looking at this, we can safely drop our port code because it doesn't have any relevance to our analysis. It's just the same port. It's another representation of the port name. We can see it here. Yeah, for Boquillas is 2410, and for Brownsville is 2301. So we can safely remove that. We use the drop method, specifying the port, the column name, and also we tell the method to use the axis 1. The axis 1 is this one, all the column names. By default, the axis 0 is per row, so we don't want to remove any row, we want to remove the full column. So that's why we use axis 1. And in place true, it means that it will drop the data and save the change on the data on the same data frame. So we can do the same on the border. We know that there is only one value for the border, and the state also only has one value. So we can remove those. And now we have just a cleaner data set, just including the port name, the date, the measure, and the value, or the number of counts. So with this, we can ask some questions, or we can answer some questions here for like the amount of people crossing per year, the amount of people crossing per month, comparing the ports, which one has more than the other, which kind of vehicles are there, how many type of vehicle cross the border per port, and the last one, which is the business port. So for the first one, we are adding a new column, the data frame year, the year column, and basically is we are grabbing the year from our date. We can see here that we have the year here now as a value. So with that, we can group our data based on the new column year, make a zoom, and reset the index to get this value, our year crossing dataset. And then we can use Seaborn to display a bar plot using the year and the value, and set a nice title here to display the information. And we can see this is the total count per year of order. So the highest was on 1999, and then it started to decline. Probably this was because the highest violence rate on the Mexican side of the border, probably this is causing this drop in the data, and then it started to go up again, and then we have the coronavirus here. No, not really. This is only up to February, so there is no more actual data. That's why we only have fewer values for the 2020 year. But this is the total number of people crossing. We can change that with an average, and yeah, the average is a very a little different on the latest years. So this gives us an insight of how many people crosses per year. We can also add the column. We can look at the data using filtering by month. So we are gonna do the same, just add the month column with a valid value, and then display the same bar plot, but with our month and value data. And we can see that December looks to be the busiest one, and March, probably March is related to Holy Week in Mexico, and a lot of people go to the US, and December also to travel there. But again, we are summing all the total values, so we can use the mean, the average, and it's not very different from our sums. So we can see that December is the busiest month on average on all of the years. So the next question is, for the next task is to compare the ports. So we can group by port name and then sum the values and display that. So we can see how many people enter per port. And we can see that the busiest one is El Paso, Texas, followed by Laredo and Hidalgo. But again, we are using the sum. We can just display the average, and it's not very different. It's not very different. Just we can see that the boquillas is not used at what is very has less people crossing there. Probably just a border for trains or trucks, stuff like that. So the next kind of the next task is just to be aware of how many vehicles or vehicle types are there, or how many people enters per vehicle type. And again, we group by, or now we changed our column to the measure. The measure is the type of vehicle, and do a sum and draw that plot. I just switched the variables, the X and Y variables, to use display our vehicles on the Y column. So we can see that the most passengers are by personal vehicle, and again we use switch from the total amount to the mean to the average, and it's not very different. So yeah, it's still the same. We see the personal vehicle passengers are the most frequent, and the most frequent vehicle type used to cross the border. With that, we can use we can also do a group by to display the type of vehicles per port. We can group our data by more than one column. We are grouping by measure and port name, and we are going to display a bar port, but using 3 variables. We use the port name on the X value, the value, the total count on the Y, and the hue is the measure. The hue is like adding a second column there. So we see that these are grouped by, we have our hue here. It's different columns, different color for each of the columns based on the vehicle type. So we can see here that on El Paso, we have more personal than anything, but also has the highest rail. I think that's the color for rail, probably rail or personal vehicles. Not sure with this. We also have on Laredo, we have more trucks and bus passengers based on the color of the measure. So do you have any questions so far?
No, everything is cool.
Okay. So the last task or this question is, which one is the BC sport? So we saw here that for 2020, there is small data only to February. So we're gonna grab a list of all the years, a unique list of all the years, convert it to a list so we can remove the year 2020. You can see that we have all the year from 1996 to 2019. And we can look at our data grouped by port name and the value sum. And we have that, we are sorting this descending. So the highest port on total with a total amount of values is El Paso. So what we are gonna do here is to iterate doing a for each of these years. We are gonna filter our data set by that year and get the highest, or the port name with the highest amount of people crossing it. We are going to store the value on this variable. That is, it will be a list, and we are going to store the BC sport on a dictionary. So we have here our for each year in our years list. We are filtering our data by the year and storing that on a data frame, the df1 data frame. And on that data frame, we will group our port name and get the sum. We are gonna doing this just for a specific year. And on the BC sports variable, we are gonna update it and adding the year, and then the port name and the value. And on our values variable, we just are adding the value. And with that information, we can plot years and the values. I'm going to run it right now. So we are just looking at the BC port on each year. We can look at that on the BC sport in our BC sport value variable. We just add it here, and we have that all of them are from El Paso. So each year El Paso was the BC sport, and we can see a tendency here. Again, it's dropped. It started declining on 2006, and then started a bit of going up, then drop it again. But we are using the total amount on the year. We can just okay, we can show the same data as a data frame using the Pandas create data frame from a dictionary. This is our dictionary, and then just adding an index. The index will be our year, and the columns will be the port name and the count. But we are looking at only El Paso, so we are going to use the same logic, but instead of just filtering by the year, we are going to filter that the port name is not El Paso to see if there is any other ports that were busiest besides El Paso. It's the same logic. We have our values, very busy sport. And the graph, it's not very different. We have almost the same tendency here, but our BC sport are different now. So we have that from 1996 up to year 2K. Hidalgo was the BC sport, and from there, Laredo has been the BC sport each year. So, okay, that's all I have for now as a basic introduction to the exploratory data analysis. I don't know if anyone has some questions or related to the data that probably we can answer. Just look, writing some code right now or something. Okay. So to wrap up our things, our session, we talked about what is artificial intelligence, how we can define that. We are now sure that we need a lot of data to start working on this kind of project. So it will be a good idea if you want to start start looking at this artificial intelligence, machine learning stuff. Sorry?
Hey, Zeus, this is Scott out in Austin. I wanted to ask you a question.
Sure.
So you're showing off the artificial intelligence and machine learning and what you've learned. Where did you go to learn that, or what was your path to get to that knowledge? And I'd be interested in hearing everybody else's interest in artificial intelligence and machine learning, you know, as something that we could incorporate in the way of training. It's something that Eduardo and Ashish and I have been bouncing around. We're not decided on it, but we are interested in hearing what you guys have to say about what you just saw and what it could do later on for projects.
Okay, well, I'm enrolled on a postgraduate program, and I'm following this course path. So the first thing that we learned was just programming in Python and all the libraries, the basic for the libraries like Pandas and Numpy, the visualizations. And right now we are on the on more specific machine learning stuff like regressions, linear regressions and that, but I'm still learning that. So I focus it on just the exploratory data analysis. I have some other resources to share with you after the meeting. There are some very good videos on YouTube by Microsoft. Microsoft wants to, it's like if Microsoft wants that to everyone to learn Python, they have a very good videos, very short videos, but it's a good resource just to learn basic stuff on Python and exploratory data analysis and specific stuff related to machine learning. So I'm gonna share those links to you after the call.
Awesome. Awesome. And what is everybody else's feeling on the phone right now? I know I'm kind of hijacking the questions, but what is everybody else's thought as developers? What do you guys think about machine learning and artificial intelligence? Because the reason I asked that question is this could be the type of projects that we go chase after, right? So I want to make sure that we're finding projects that y'all want to work on. Does that make sense? Nobody?
I mean, I would be really interested in working on some stuff like that. Sounds pretty fun. I also started reading recently something about machine learning and started relearning the, for example, matrix analysis and matrix operations. But yeah, sounds fun.
Yes, Hector here. Some time ago, Daniel, Diego, Jorge, and me took a course in machine learning. We saw almost everything that you told us today, and I do believe that, well, by myself, I would love to work in a project with machine learning and artificial intelligence.
Right on, Hector. So how often do you guys see artificial intelligence or machine learning cropping up in the projects that we're playing with today? Do you see an opportunity to utilize it going forward?
Well, for me on current projects, I haven't seen anything related to machine learning, but there's always the data. So there is a lot of data there that can be easily exploited, analyze it, and use it to start working on machine learning projects. So probably not directly, but yeah, there is most of the projects involve gathering a lot of data, and having data on this kind of projects is crucial. The more data you have, the best model or the most precise mathematical model you will end up with, and you can have the software making more accurate or more precise decisions, more smart decisions.
Yeah, more data, better decisions. Understood. Awesome. Well, I appreciate you letting me ask those questions. I'll leave it open to anybody else.
Okay.
Jorge here. So also, as for machine learning, it's really important that you have what you want to do with this data. I mean, it's the main topic has to be what is going to be solved with the machine learning stuff. So, for example, I'm only thinking on CSC project. If you have all this data related to people that are offenders or something like that, you have all of the data, what they do, what is the felony or whatever it is. You have to create a scenario that this machine learning could help to avoid, for example, possible future offenders. I mean, if you have some sort of database that is related to a certain topic of ethnicity or a certain range of age of people, you can start thinking of how to avoid people to get in jail or some sort of those things. So if we are thinking of start searching for projects over there, it could be nice to also see what could we offering related to the problems on future clients.
Yeah, I like the way you're thinking right there. That's exactly what I'm thinking of. Because if we're on project and we're seeing all the data that they're dealing with, then we should, if we could, have the eyes to propose to them, hey, we see a chance for an artificial intelligence machine learning project that will do X, Y, Z for you. That's extending ourselves within the client. So I appreciate that thought right there. That's awesome.
Yeah, probably talking with if the project has some kind of report, talking with the people involved in consuming those reports could give us some insights on what they are using reports for, what they are trying to plan for future using business intelligence and stuff like that. So business intelligence is just the first step. It's just gathering data and analyzing the data.
Yeah.
But from there we can use it as a foundation and start working for machine learning.
Start seeing scenarios and opportunities to present more. Yeah, I understand.
Yep.
That's awesome. Thank you for letting me ask and answering the questions.
Thanks. So just to finish the wrap up, we saw the description of what is machine learning and artificial intelligence, some basic insights on the exploratory data analysis. We saw some visualizations there. Actually, there are a lot of more different graphs, but this data set was not very friendly to showcase that. But I think it worked for just an example of what exploratory data analysis is. Also, the tools that we use. So if you want, you can download Anaconda. It's a very nice package. They have also, if they include all of the machine learning and artificial intelligence packages used by Python there. So you can just download it, install it, and start working on that without worrying about downloading more packages or something. So it's a very complete set of tools. and the Jupyter notebooks are very good also. And well, that's all. Thank you all. And I don't know, Paulina, if there's something to add.
No, not from my side. Thank you very much, Jesus, for this virtual lesson. And well, thank you everybody for joining. Just to let you know, next week we'll be having another virtual learning session. It will be by, oh, sorry, I just have the information here in one moment. It will be by Kyle, and I'm going to send you the invite today, later, okay? So just
Okay.
keep that information in mind, and well, thank you, Chuy, for this.
Thank you.
Thank you. Bye.
Thank you.
Thank you.
Have a nice day.
Thank you.